Now this lesson, to help us with our coordinate geometry, is a review of what you learned in algebra about slope. You know, about how steep a line is and the direction it's running. So I want to introduce you to Mr. Slope Guy, who is going to help us learn about or remember the properties of slope. Here he is. Isn't he cute? Okay, there's 4 different kinds of slope. So let's take a look at each one. First of all, his left eyebrow here. You see how as I draw it to the right, it rises or climbs to the right. And so lines that climb to the right, those have positive slope. Now, if I'm moving to the right, look at this right eyebrow. If I'm moving towards the right, I see this thing falling. This is to remind me here, his eyebrow here, that that's got a negative slope. So if it rises to the right, it's positive slope. If it falls to the right, it's negative slope. What if it doesn't do either one? What if it's just straight up and down like this line? What kind of slope does that have? You might remember that some slopes are undefined. If it's a vertical line, that's undefined slope. So this thing has an undefined slope. We're going to use Mr. Slope Guy here to remember that. That's the nose here. This is supposed to look like a U. I hope it does. That's to help you remember it's undefined. And then some lines don't rise or fall either this way because they just stay flat. So his mouth helps us remember that. The horizontal lines, they have a slope equal to 0. And that's what those dimples are about. Slope is equal to 0. Let those dimples remind you of a 0. Okay, so those are the 4 different kinds of slope. More important though is how do you calculate slope? Let's look at the slope of AB here. You guys will probably remember some formulas and some tricks, some things to remember. Let's review those. First of all, we usually use the letter M to stand for slope. I'm not sure why. Somebody look that up and find out. Research the reason why we use M as the letter for slope. I'd love to know, and I'd probably reward you richly, maybe with some extra credit if you can bring me a documentation about it. Anyway, the slope is equal to this formula where we subtract our y values. Usually that's written as y2 subtracting y1, and then we divide that by the difference in the x values in the same order. So our x2 subtract our x1. It's important that we keep that order the same and we have the y values over the x values. You guys will probably also remember this as rise over run. The rise is the y's, difference in the y's, and the x's tell us the difference in the run, or the run. So rise over run. All right, now rise over run is usually used when you're looking at it from a graph. If you go from A to B, I want you first of all, what kind of slope is that? Positive, negative, 0, undefined. Hopefully you're saying negative to me right now. Anyway, if we go from A to B and we look at the distance that we maybe drop, let's drop first. We build a right triangle like we did when we did the distance formula. We're going to build a right triangle here, and we are going to count that drop and that run across. So the rise is this vertical and the run is this across here. Let's give that a count. Starting here at A, 1, 2, 3, 4, 5, 6, 7. So, and it went down. We want to make sure we get negative on that. -7 is the rise. And then across we count from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So positive 10, since that was in the positive direction towards the right, that's our run. We put those numbers over each other, rise over run. So the slope on this line is going to equal our rise value of -7 over our run value of 10. And if we can reduce that, we will. This doesn't happen to reduce, but look how it's negative, just as we predicted it should be. So that's how you do it from a graph. If you're calculating the slope from a set of points and you don't have a graph and you don't want to take the time to graph it, this is my recommendation. You see me do this point stack a couple of times, and I want to make sure you do it here too because the order matters when you're doing slope. So I'm going to stack my points. I'm going to put 5, 2 in a stack here with the -6, 18. And according to the formula for calculating slope, these are subtractions. So I'm going to subtract those coordinates and look at what I get. So if I take 5 from x here and subtract the -6, that's really plus there. So 5 plus 6, that gives me 11. And then I do the same for my y's. I have 2, and I'm going to subtract 18. So that gives me a negative number. That's going to be -16. These two numbers are the same thing I would have gotten had I graphed it and built the triangle. This would be my rise and run numbers. Which is which though? Remember, the rise comes from the y's. In fact, that's a little memory trick. See how that rhymes? Rise from the y's. So, which of these was the rise? It was this one. This is the rise because that came from the y's. That means our x's gave me the run. And so my slope, my answer for slope on this, is the fraction with the rise, or negative 16 over 11, the run. Negative 16 over 11 is the answer. Okay, let's do it. I want you to try these. Yeah, these are a try these for you. I'm going to have you pause the video, come back to it, and see how you did. All right, for the first one here in the graph, if your answer was 8 over 3, then why don't you fast forward to the next part, because that means you did it right. If it was not, I'm going to go through it here with you. All right, so I'm going to build the right triangle. I'm going to start here and I'm going to draw my line going up. That's going to be my rise. And then I'm going to come across for the run. Rise up, run across. Count it out with me. From here, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. The rise is 8. And on the run across, it's 1, 2, 3 across. So putting the rise over the run, the slope of this thing is just as I said. It's going to be 8 on the rise, 3 on the run. And that does not reduce. So that's our answer. All right, for this one, when you had to calculate it, if you got negative 1 as your answer, then you're correct and you probably could fast forward. If you didn't, then follow through the steps here with me. My first step is I'm going to make a point stack out of this so that I keep everything in the right order. So I've got negative 1912 for my first point and negative 310 on the second point, just in the point stack. Then with the point stack, I'm going to subtract. So each one of these, subtracting them out, we're going to take 19 minus that negative 3, so I'm going to make sure to go 19 plus 3, and 19 plus 3 is 22. And then on my y's, same thing, a negative 12, I'm going to subtract the 10, and negative 12 minus 10 gives me negative 22. All right, now make sure the rise is the y's. The rise over the run is going to be negative 22 over the run of positive 22. That simplifies, so I want you to simplify it if you can, and that just simplifies down to a negative 1. So our slope is negative 1. Now, parallel lines have a special property, and it's in their slopes. It makes sense. If we have parallel lines, that means that one line runs along the same direction as the other line, and they always stay the same distance apart. And in order to do that, if these are going to be running parallel to each other, they have to stay at the same steepness or the same slope. So slopes for parallel lines are equal. And that's important enough, you probably should pause this video and say it out loud. Even if there's people in the room, stop and say slopes are equal for parallel lines. So our job here is going to be to graph a line that's got a parallel relationship to our line AB. So in order to do that, I have to figure out what the slope of AB is. So let's go ahead and build a right triangle and count it. We'll get our rise and our run. So our rise here, and then our run to here. Counting the rise, I see 1, 2, 3, 4, 5. So the rise is 5. And the run I see is 1, 2, 3. Actually, let me write that down. So 5 there. The run again is 3. So I put the rise over the run, and I want a 5/3 slope. Okay, so if this is the slope, then I would like to draw a line that has the same slope so that they're equal and they should be parallel. I'm going to I didn't give you guys a point to start with, so let's pick a kind of a random point, I guess. How about we start right here at 4, 2? You have to have a place to start. Now, I'm just simply going to copy the same slope that I have from AB starting here. So I'm going to, from that point, I'm going to rise 5. 1, 2, 3, 4, 5. Right there. And then I'm going to run 3, 1, 2, 3 to here. And what that does for me is gives me a second point that I can draw my line through. I'm going to get a ruler for this one, or straight edge. So here's my line through those 2 points. And doesn't that look nice and parallel to the original line? So AB here is running parallel to the line we drew because we copied the slope of it. And you might want to, in your notes, just make a little note there that that was 5 on the rise and 3 on the run. So we just copied it. Perpendicular lines. For perpendicular lines, they can't have the same slope or they'll stay parallel. We do need perpendicular lines to cross. But in order to get them to cross, we have to do something kind of special with it. And to show you what that is, I'm going to actually start by asking you guys to calculate the slope of this first line. It might just be the same as the last one, but let's double check it. I think I probably just copied and pasted this graph. Yeah, 1, 2, 3, 4, 5. This is still 5 and 3, so it's just like the last one. All right, so the slope of this one, the slope for AB is 5/3. To run perpendicular, what we have to do is we have to take this slope and we have to change it in two ways. The first thing that we do is we make it the opposite sign. So I'm going to have you write this in. The slopes are opposite, and what that is a plus or a minus change. One's positive, one's negative. They're opposite, and they're also reciprocals. Do you remember what reciprocal means? To do a reciprocal, I take my fraction and I flip it. So if it's a fraction with a numerator and a denominator, there's a number up here, there's another number down here, and it's going to be reciprocaled. I'm going to flip it. Both of those things happen. So how does that work on our example? Well, if I'm going to change the sign, I notice this is a positive slope. My line rises. So I'm going to make the new slope a negative slope. And then I'm going to reciprocal the fraction. So instead of saying 5/3, I'm going to flip that around, and I'm going to call that 3/5. This is the slope for the perpendicular line. So to tell you that, I'm going to write slope, and I'm just going to put our little perpendicular sign on that. The slope of a perpendicular line is going to be -3/5. Let's graph that. So let's go from that same 4-2 point like we did last time. Only as we build the slope, we need to make sure to rise. Let's say -3 for the rise. I'm just going to make a note here. -3 is going to be our rise, and then 5 will be our run. We'll give the negative up to the 3 here. All right, so from this point, my rise is -3. I drop 3 units, come down 3. And then I run 5 units, 1, 2, 3, 4, 5, and that's to the right. So going down 3 and 5 units to the right, I'm going to build a new line from this with the slope. Okay, now let me draw the line in here, and I'm going to give it a color. Maybe you can see this better. I'll do it blue. Okay, so the line between these 2 points, if I extend it out, what I should get here is a nice perpendicular line. And if you can see here, this looks like it's pretty good. That looks like it would make a right angle right there. So that's how you get a perpendicular. Now let me just review those steps one more time. To do a perpendicular line, you have to take the slope and find its opposite reciprocal. Okay, so that means that I'm going to do 2 things. I'm going to change the sign and flip it over the line. Change the sign, flip it over the line. Let's say change the sign, cross the line. Okay, so a couple more examples. This last one we saw was 5/3 for one of the slopes, and this new slope is -3/5. So we change the sign and flip it across the line. Another example, let's say you had a slope of -1/4, and you wanted to change the sign, then it would become positive, and you flip it across the line to reciprocal it, you're going to get 4/1, or just 4. Okay, so one thing you might see sometimes is the rule for the slopes of perpendicular lines is that slope number 1 multiplied by slope number 2 is always going to equal -1. It's a -1. Does that work here? Does slope number 1 times slope number 2, if we multiply these, do we get -1? Well, I think we do, because what's going to happen? The 3 here will cancel the 3 here in the multiplication. The 5 here will cancel the 5 here. So all we're left with is just the 1s, the fraction. They multiply together, but we have this sign. So it's -1. And that's going to be the same for all of these. All right, so there's your overview of slope. I hope you've learned this before, and this is just review. We'll definitely practice it to prepare us for what comes next.